What's happening, y'all? So per Austin's request, here is numbers 1 and 2 on the day 5 homework. These have to do with finding limits of trigonometric functions. So without further ado, we're going to need to know the Pythagorean identity. So if you don't know that, you're going to need to know that. And from that, we can rewrite cosine squared is equal to 1 minus sine squared theta if we solve for cosine squared theta. So that's also true. So you can see why I did that, I think, over here. So what we got is the limit as theta approaches power over 2, sorry about that, of cosine squared over 1 minus sine of theta. So I see cosine squared, my brain immediately goes to Pythagorean identity. Backtracking a little bit, of course, first you want to plug in pi over 2. When you plug in pi over 2, you're going to get 0 on top and 0 on the bottom, which is indeterminate form, so we got to rewrite. So the first thing I'll do is rewrite the numerator as 1 minus sine squared of theta over 1 minus sine of theta. Well, then you got to go back to your brain cells and you got to remember something like this or something like this are both difference of squares, and that's basically what you have in the numerator here. This is a difference of squares binomial. Square root of 1 is 1, square root of sine squared is sine. So the same way that you would factor one of these up here would be x plus 1, x minus 1, or 1 plus x, 1 minus x, same difference. You're going to do that here as well. So now we're going to go limit as theta approaches pi over 2 of 1 plus sine of theta times 1 minus sine of theta over, I'll use that as a subtraction. 1 minus sine of theta on the bottom. These two things right here cancel out. And now we've got limit as theta approaches pi over 2 of 1 plus sine of theta, and we can plug and chug at this point. So we've got 1 plus the sine of pi over 2. Pi over 2 is at the vertical position in the unit circle, and the y-coordinate there is 1. So 1 plus 1 equals 2. On to the next. First thing I see is limit as x approaches 0, and I've got a 2-part numerator. So whenever I see a 2-part numerator and a 1-part denominator, like 2 terms up top separated by plus or minus, and then 1 term on the bottom, I always know that I can split up the 2 fractions, so that's a possibility. Plugging in 0, I get 0 plus 0 over 0, so it's indeterminate form. So we do have to rewrite it. So again, I'm seeing 2 terms up top, 1 term on the bottom. That's usually a pretty good indicator that you can potentially separate into 2 fractions. Let's see what happens. Limit as x approaches 0 of x over x plus limit as x approaches 0 of sine of x over x. That's the same idea of doing like 1 plus 2 over 4 is the same as 1/4 plus 2/4. Right, that's basically what we just did. So this is actually kind of nice because if I look at the first part here, we know that that's just 1. And then we also have this guy right here, which is one of our identities that we just talked about in the notes for section 5. We know that the limit as x approaches 0 of the sine of something over that same something is also 1. So this one is also 2. And that's it for now. Hopefully this helped. I'll catch y'all next time.